Hey everyone, welcome back to Advanced Blockchain Development Tutorials. Today, I'll be showing you something I did to the Cardgame contract to start getting it ready for us to add DAPP Network services. So we'll be back in the Cardgame contract, which you might remember from the first developer course, or from the Block.one online Elemental Battles developer course if you've done it. Otherwise, you can go ahead and download the information in a bit. And let's go ahead and pull up a terminal here. Now, the first thing you're going to want to do in your Zeus projects folder, or whatever folder you're using for projects, is run Zeus unbox Cardgame. Now that will create a new directory called Cardgame and unbox the Cardgame box in there, including all the DAPP Network services, and a version of Cardgame that has several DAPP Network services integrated, including vRAM and vAccounts. It's going to take a little while, because it's spinning up a whole bunch of things, but go ahead and run it now. Once that is done, I'm not going to run it because it'll just eat up processor speed. Once that's done, go ahead and copy the files in the zip that's attached, that's in the text description here. There's a Cardgame folder there in that zip. Paste it over and merge it in with the Cardgame that Zeus Unbox creates. What I've basically done is rolled back vRAM and vAccounts so that we have the Cardgame contract essentially as it was at the end of the Block.one tutorial. And it's ready to add vRAM and vAccounts too, so that we will be able to learn these services easily. All right, so go ahead and paste that Cardgame folder in with the Cardgame folder that is unboxed by Zeus. And I will show you the changes that have been made from the end of the Block.one tutorial. Okay, so if you've taken the first developer course or the tutorial, these are the changes, the little differences that are in already in order to prepare us for some DAPP Network usage. So in the Cardgame folder, let's clear up here. In the Cardgame folder, you can see there's a number of things that Zeus Unbox has created for us, more than just the contract and front-end folders that we have normally in our Cardgame folder when we're working with the Elemental Battles card game. A couple of changes have been made, though. If you go into contracts, there's an EOS folder because maybe there will be other blockchain folders in here later, right? And then you can head to the Cardgame directory within that EOS folder. So we are in this directory right now. And in that directory, I'm going to go ahead and open the Cardgame CPP file, which, if you remember, is the C++ part of the contract that has all the public-facing actions, right? There's actions you can actually call on the blockchain, not the private functions. Those are in gameplay CPP. And here we have, this is the familiar Cardgame CPP file. This is the one basically that the Block.one tutorial ends up with. And if you took the developer course, these will probably all say action instead of void. It's just a macro. It's fine either way. The major change that has been made to the contract is that instead of passing in variables one by one to all these functions, passing in arguments one by one to all these actions, like name, username, and whatever else we passed in here, I don't know. We didn't have that, but there were lists of parameters. We include them all in a struct that is entitled payload. All right, it's of the player struct type, which is defined in the header file as usual, and we call it payload. And this will pass in all the information from the front end. A JavaScript object will be passed in, and on the contract side, it's received as a struct called payload. That way we can do, where's that play card action? Now you'll notice this is actually a play struct here, whereas in the other functions, it's a player struct, because normally we're just passing in the player name. In order to log in order to start a game, in order to end a game, we're just passing the player name. But in order to actually play a card, we're passing something different. We're not only passing a player name, we're also passing the card index that the player has selected. So we need to go check out our header file as well. You'll see there that in the public section, we have a couple of new structs defined. a player struct, which just has the username serialized, and this is what we're going to be generally using for all actions that don't require information beyond the player name. And of course, our declarations have been updated to not have name username, but to have these structs. And then a play struct as well, which not only has the username serialized, but also the player card index, which is the index of the card in the player's hand that the player has picked to play. Okay, so here's the play card action. In the old version, we had name, username, and then a uint 8t, and I don't remember what it was called, maybe something like card index or selected card or something like that. Now, instead, all that is put together in this struct called payload. And if we head back out to where contracts was, right, we see there's also a front ends folder, which is very similar to the front end folder that we had in the earlier tutorial. If we head into front ends, there's one main front end. This is a little bit of new territory. It's called main. Just remember, the main front end here is called main. We're going to reference that later. And there's our source folder. That looks very familiar, this public source and node modules thing, because we've worked in the front end folder before in the card game tutorial. And we had a source folder. So let's go into that source folder, and inside we see the familiar actions, components, constants, reducers, services, and store for our React Redux node setup that we had going on in the Elemental Battles tutorial itself. We also have EOS.js 2 wrapped in right here. I think we were using an older version of EOS.js earlier, but now we've upgraded to EOS.js 2. So if we head to the services folder, and our old friend, the API service JavaScript file, handles everything related to the blockchain. So the front end does its work, and when it needs to post to the blockchain, post an action to EOS, when it needs to push an action, when it needs to get any information from the blockchain, it does that via API service. So let's look at API service and see what has changed. Well, first of all, like I said, there's EOS.js 2. But the second change is that I actually implemented this change for now. We might be restructuring this a little bit later. Our take action function, where we posted the smart contract action when we want to call, and also the data we want to send to that action. That wouldn't work with the new contract setup with a payload struct, right? Because this data could be any number of variables, and we're sending them all in. The contract would object and say, wait, no, I just want a payload struct, and you sent me a name and an integer and a string, or like a vector of integers or whatever. So right down here, I actually kind of wrapped that data value object that comes in, like into an object that has payload. Like the data value object is wrapped in another object, so that now it will be received by the contract and will be correctly received. And the contract will receive its struct that it's looking for because of this one line here. Those are the changes that have been made in order to get us to a point where we really can learn to implement vRAM and then learn to implement vAccounts to Cardgame. That's the only basic change. There might be a little bit of restructuring here, but I look through, I don't really see anything different it's a pretty straightforward file. So you can look through it yourself if you want. There might be a few other minor differences, but we're going to implement vRAM and implement vAccounts. This makes a great starting point. Now, since we're running in Zeus here, I gotta go up who knows how many times. Okay, since we're running in Zeus here, we can actually use one command to spin up Node.EOS and deploy this contract to it. And then we can use one command to run our front end. All right, we'll have to create an account on the Node.EOS, but that's okay. We'll do that in a second. So let's go ahead and use Zeus migrate. There are various commands. If I do Zeus help, we can see all of them. Various commands available for Zeus. There's build, compile, which will compile all the contracts, and that's a part of migrate. We've got deploy here to deploy a component. A large number of commands available. We're going to be using, to test runs a full test, we're going to be using Zeus migrate, and then we will use Zeus run in order to run the front end, which, as we saw, is named main. So let's first do Zeus migrate. This might take a little while and might eat some CPU up. I'm going to probably turn myself off during this. All right, looks like migration is done successfully. So if I do Kleos get account, which as you'll recall defaults to local node EOS, and I ask for EOS.io information, there it is. We can see that there is indeed an EOS node that's running locally. Now, in order to interact with the Cardgame contract that's been deployed, right? If you go up, you see that the Cardgame contract was deployed to Cardgame 1111, which indeed has this information, right? And if I get the ABI for Cardgame 1111, we can see all this information about the smart contract that's been deployed, the actions that are involved. We know that the contract's deployed, it's running, local node is running, but we need a user account in order to use the card game. So you can't just create account. You can't actually do that because the EOS.io system contracts are deployed. So you have to use the syntax for Kleos system new account, and then we'll have to do stake for CPU, stake for net and RAM and stuff like that in order to get the new account created. So with that in mind, we do need to take a look at our Kleos wallets. I just launched KeosD, but there's no wallets listed. I think that we have a tutorial wallet though, right? Kleos wallet unlock tutorial. Yes. Now, if you remember, in my default directory here that I've created for the purposes of this tutorial, when I created my Kleos wallet, which I named tutorial, I saved the password for that wallet to a text file, which is good because now I need it in order to unlock the wallet. So if I list with hidden files, I can see that wallet text file right here. I'm going to take a look at it and copy this out, :Q to exit. And now I can Kleos wallet unlock tutorial, paste in that password, and the wallet is unlocked. Great. Now I've already imported the development key here, which is the key that you need in order to control the local EOS.io and do things like just create accounts and send sys randomly to things. But if you haven't done that, or if you don't know that private key, go to developers.eos.io, and in the Getting Started tutorial 1.5, create development wallet, and it's a publicly known key pair, so don't use it anywhere else, right? So I can say Kleos wallet import, it'll ask me for a private key, I paste in that private key. In my case, it'll say non-existent wallet because I've named my wallet tutorial. But if I actually give it a wallet name and paste it in there, in my case, it'll say key already exists because like I said, I've already imported it. But in your case, you'll need to do this in order to get that development key active. So that lets you do things now like Kleos system new account, and I actually am going to need a public key here. So if you remember, I also had a key pair that I created here, and I saved it to keys.txt back in the Kleos tutorial. So let me get that up, this private key right here, so that 8F7 can be the public key that controls my wallet. So I need that public key actually. System, new account, the creator of the account. Oh, actually I need options first. And the options are stake net, stake CPU, and buy RAM kbytes. So what I'm going to do is Kleos system new account, and then the options. Stake net, 10 sys, which is then the local version of EOS. When you have a development node EOS, you use sys instead of EOS. And then buy RAM kilobytes. Let's do 30, I don't know, 300, why not? And then the creator is EOS.io. The account, we'll call it game player 42. And then the public key. And if you just paste the public key once, it assumes that that's the owner and active key. If you wanted a different one, you could paste a different active key afterwards. That should work. It did. We created an account, new account. We bought some RAM for it, and everything's all good to go with that account. We can check to make sure. Kleos get account game player 42. And there it is. It's got, like we said, 10 sys delegated to net and CPU both. And it's got some RAM. It is using a little bit because every account uses a little bit, but it's got most of the 300 kilobytes we gave it. So now that we have an account, we can head back to our card game folder. All right, we're in our card game folder. This is where our Zeus unbox was, and where we made those updates to get rid of vRAM and V accounts, but also to on the other side to have that struct, right? And this is where we run our Zeus commands. So I already ran Zeus migrate here in order to deploy the contract to Node.EOS. I don't need to do that again. The contract's compiled, the contract is deployed to a local version of Node.EOS, it's ready to go. But I don't have a front end going. I can't actually interact with it in any way other than just sending it Kleos commands, which, while I could do that, it's not particularly fun gameplay experience for actions that require things like card index. And so let's run Zeus run frontend main. If you remember, in the front ends folder, there's a main folder, and that is where our front end is located. This will run our React Redux front end right here, and so that we can access it from a browser and interact with our local version of the contract running on local Node.EOS. That was fast. We started up quickly. All right, so if we open any browser and go to that address that it's showing us it's running on, it will take us to Elemental Battles. All right, this front end is running locally. We go ahead and enter our account that we have created, and also the private key that matches the public key that we used to create the account, okay, that we just did that, right? It might be in that keys text file if you're really following along. The private key that matches, we log in, and hey, we're in, and it looks like everything is working great. Let's start a game. All right, so this is running locally. We can go ahead and check that right now. All right, so I'm going to open a new tab since we're running the front end in this one. If I Kleos get table, all right, locally, and I need to specify the account, the scope, and the table name. Let's get the table, what was it called? Users? Let's get the table from the account Cardgame 1111. And then we need the scope, which I believe we don't scope the tables to users, right? And then we need the actual table name, users. Hey, there we go. Okay, we have, yes, locally, we have user gameplay 42. He's playing a game right now. There's 5 player life, 5 AI life, and here's the deck. Zeus has spun up a node for us locally with Zeus migrate. And then we did have to do some account creation stuff, which that was a little bit of a hassle. But one command, Zeus migrate, spun up a local node, built the contract, deployed it to the local node, right? And then that one command, Zeus run front end main, ran a front end for us so that we can actually play our app. All right, so this is the framework that we'll be working with in the Zeus development kit in order to add vRAM to this very game. Because like right now, all this stuff takes a huge amount of RAM. It would be feasible to deploy this game to mainnet maybe because the users are paying for the resources, right? But it wouldn't be feasible to hope to do it at scale and have the developers pay for the user's RAM and resources, which is a more adoptable model. So for that reason, for other reasons, we will be adding vRAM to this game so that our storage is more affordable. The user's data is only kept in RAM when the user's active session is going. And when the user is away, it's evicted to vRAM. We'll be adding that strategy over the next few lessons. So install the IDE of your choice. Okay, VS Code if you don't know. Install the IDE of your choice before next lesson so that we can just open that folder and start working with the code in a more comfortable environment maybe for you than those command line editors that we've been using so far. All right, so next lesson we'll get to adding vRAM to our smart contract.